In this video, we'll be looking at different methods in order to solve quadratic equations. The most standard form that we see quadratic equations in is ax squared plus bx plus c equals 0. And the different methods of solving them are factoring, square root property, completing the square, and using the quadratic formula. If you're solving the equation by factoring, you want to use this method, the AC method. The first thing you do is you multiply the a and the c term and then find factors of that AC term that can multiply to get you a times c, but also add to get to the b term. Then you rewrite that b using those factors, and then finally you factor by grouping. Let's apply the AC method with this example here. X squared plus x minus 42 equals 0. So first thing we want to do is we want to identify what our a, b, c is. So a in this case be 1, b is 1, and c is negative 42. So the AC method says we take our a and our c, so we take 1 times negative 42, multiply them, and we find factors of negative 42 that add up to get you the b value, which is 1. So in this case, it would be positive 7 and negative 6. Then what we do is we replace the middle term, the b term, by 7 and negative 6. So we have x squared plus 7x minus 6x minus 42. Then what we do now is we group up the first two terms and the second two terms, and we factor each set of parentheses. So for the first set, we can pull out our greatest common factor would be x, and what's left would be x plus 7. And the next term, the next set of parentheses, negative 6x minus 42, we can factor out a negative 6, and it's left with another x plus 7. So when you're factoring by grouping here, you want to make sure that you want to see that the two parentheses here should be the same. So now that they are the same, we can actually factor out that common x plus 7, which gives us the remaining x minus 6. And we group those two up, and that's equal to 0. So now that we factored it, all we got to do is just set them both separately equal to 0 and solve for x. So if we subtract 7 here, we get x equals negative 7. And if we add 6 here, x equals to positive 6. So that right there would be the solution to the quadratic equation. So another example, 3x squared minus x minus 4. Again, identify our a, b, c. A is 3, b is negative 1, and c is negative 4. The AC method is we take our a and our c, so 3 times negative 4, negative 12, and then we find factors of negative 12 that add to get you negative 1, which coincidentally in this case would actually be the same terms 3 and negative 4. So that adds up to get you negative 1. So then we replace that middle term, that b term, with 3 and negative 4. Now it doesn't matter the order we write them. So this time I'm going to write this as 3x squared, and I'm going to put the negative 4x first and the 3x afterwards. So it doesn't matter what order you write it in, as long as the middle terms add up to get you your b term is all that matters. Now we group up first two terms and second two terms, and we factor, find the greatest common factor of each. So 3x squared minus 4x, the greatest common factor would actually be x, and we factor an x out, we're left with 3x minus 4. The second set, 3x minus 4, technically there's nothing in common that we can pull out, so what we do is we pull out just a 1, because we need to factor something. Best way to factor is to pull out a 1. It doesn't change the inside, however, what it does let us do is that we notice that the two parentheses now, 3 are both 3x minus 4. So then we would pull out that common term of 3x minus 4. And then what's left over is the x plus 1. And we group those up. And that's equal to 0. Again, now that we have it factored, set them both separately equal to 0 and solve for x. So we add 4 over, 3x equals 4, and divide by 3, so x is equal to 4 over 3. And then over here, I subtract 1 over, so it gives us x equals negative 1. So that right there is our solution. Let's look at one more example for factoring. So we have 7x squared plus 4x minus 3. Identify our a, b, c. A is 7, b is 4, c is negative 3. Apply the AC method. So we take 7 times negative 3, which gives us negative 21. Find factors of negative 21. As we get your 4, in this case it would be the same terms. 7 and negative 3. Then what we do is we replace that middle term, the 4x, with 7x and negative 3x. So we get 7x squared plus 7x minus 3x minus 3. And then what we do is we group up first two terms, second two terms, find the greatest common factor of each. So the first one we can factor out as 7x, which left us with x plus 1. And then we have a negative 3x minus 3. We can actually factor out a negative 3. That also gives us x plus 1. Now that the x plus 1 terms are the same, we factor out that common term. And what's left is 7x minus 3. Still equal to 0. Then we just set both of them separately equals 0. So sum for x gives us x equals negative 1. And then 7x minus 3 equals 0. We add 3. And then we divide by 7. So x is equal to 3 over 7. So those are our solutions to the quadratic equation using the AC method. Another way to solve a quadratic equation is applying the square root property, which states if x squared is equal to some m, then x is equal to plus or minus square root of m. Now, how that works is if we look at the example here, for the first one, x squared equals to 4. So applying the square root property, we'll apply, first let's write this equation again. Squared equals 4. So what we do is we apply a square root to both sides of our equation. Take square root on the left, take square root on the right. Now what happens on the left is a square root of x, a square root is actually saying something to the power of 1/2. So in reality, on what's happening on the left side here is that you're rewriting this as x squared raised to the 1/2 power. Now rules for exponents states that when you have a power to a power, you're multiplying. So this becomes x is a 2 over 2, but 2 over 2 is just 1. So we get just x on the right side, on the left side. Now on the right side, square root of 4 is just 2. But square root probably is not just 2, but it has to be plus or minus 2, because think about it, 2 times 2 gets us 4, but also negative 2 times negative 2 will get you 4. Now look at question 2 here, example 2 here. Again, let's rewrite it. X squared is negative 56. Apply the square root to both sides. So again, because of rules of exponents, on the left side we know it's just going to be x. But on the right side, negative 56, first off, can be written using rules for products of radicals as square root of negative 1 times square root of 56. But we know square root of negative 1 is actually an imaginary number, and that will just be I. And because we've taken a square root per se, we should have plus or minus in front. Now 56 is not a perfect square, but it can actually be written simplified as square root of 4 times 14. Now, again, applying rules for radicals. Square root of 4 times 14 can be written as square root of 4 times square root of 14. But we know the square root of 4, that's 2. So essentially this becomes plus or minus 2i square root of 14. That's equal to x. Now, square root of 14 is not a perfect square, and it could be simplified, but the only factors of 14 we know are 7 and 2, but none of those are perfect squares. So we leave our answer as just x equals to plus or minus 2i times square root of 14. So the same can be said on this example. So we have x minus 4 quantity squared equals to 25. So first thing I'm going to do is just rewrite this equation. And then again, apply the square root property. So we apply a square root on both sides of our equation. So using rule for exponents, on the left side, x minus 4 quantity squared is being raised to the 1/2 power essentially, which then will become just 1, the power of 1. So we have just x minus 4 on the left side. Now on the right side, 25 is a perfect square. So the square root of 25 is 5, but it won't be just 5, it would be plus or minus 5. And again, the way to think about that is 5 times 5 gets you 25, but also negative 5 times negative 5. So now we have x minus 4 equals to plus or minus 5. So we can actually think about this as two different equations. We have x minus 4 equals to positive 5, and also x minus 4 equals to negative 5. So now we solve both equations separately. So adding 4 onto both sides here, and we can go ahead and do the same over here. So on the left side, leverages x. 5 plus 4 gives us 9. And then over here on the other one, negative 5 plus 4 gives us negative 1. So our answer is x equals to 9, and also x equals to negative 1. Let's look at one more example for the square root property. So we have x plus 6 quantity squared equals to negative 39. Let's rewrite it. So now we apply the square root property, take a square root both sides. So left side reduces to, or simplifies to, just x plus 6. Now on the right side, according to square root property, we know we're going to have a plus or minus. So let's go ahead and put a plus or minus in front, and we still have the square root of negative 39. Now, right away when we see square root of a negative number, we automatically think about rules for product rule of radicals. We can rewrite this as plus or minus square root negative 1 times square root 39. Because we know square root negative 1 is the imaginary number I. So we can turn that into plus or minus I square root of 39. Let's go ahead and rewrite the left side here, x plus 6. So 39 is not a perfect square. And also, if you were to simplify 39, only factors of 39 we know is just 3 and 13. Both are prime numbers, so they're not perfect squares, so we can't do any of that. So we just keep our answer on the right side as radical 39. So the last step is to subtract 6 both sides. So now we have x equals 2. So if we write this in standard form of a complex number, we have a negative 6 first, plus or minus I square root of 39. And that would be our answer. Now, sometimes there will be some quadratic equations where you can't immediately factor. This is where the completing the square method comes in. Now, first thing we want to note is in order to complete the square, your standard form, the a must be equal to 1. If it's not, you want to make sure you divide both sides to make it into a 1. So how you do this is you isolate the x terms first, and then you would take the b term divided by 2 and square it, and add that term to both sides of your equation. So then you would rewrite your perfect trinomial as x squared plus bx plus b over 2 squared as a perfect square, x plus b over 2 quantity squared. And then you would take, just like we did before using the square root property, you would take a square root both sides, and then you solve the equation and simplify. Now let's look at an example of completing the square. So we have x squared plus 5x minus 11. The first thing I want to do is move that negative 11 over to the right side by adding 11. And it will make sense why we're doing that in a second. So we have x squared plus 5x equals 11. Now our b in this case is 5. So we take 5 over 2 squared. So we square both, because we can't divide by 5 divided by 2, so we just square both top and bottom. Gives us 25 over 4. So we're taking that 25 over 4 and adding it to both sides of our equation here. Now, the reason why we wanted to add 11 over to the right side first is because once you add the 25 over 4, the whole left side becomes a perfect trinomial. So now when we factor it, we know that we don't have to go through the process of applying AC method or anything like that, because we know that when you factor a perfect trinomial, your perfect square will be x plus b over 2 quantity squared. In this case, this is our b over 2 here. So the left side factors into x plus 5 over 2 quantity squared. And all we need to do on the right side is add them up by getting common denominator. So we can write this as over 1. So we multiply the top and bottom of the 11 over 1 was 4 over 4, because that's our common denominator. Gives us 44 over 4 plus 25 over 4. So if we add that, that gives us 69 over 4 plus 5 over 2 squared on the left. Then now we apply the square root property to get rid of our square on the left. So left side we're left with just x plus 5 over 2. Now 69, immediately think of as 69 can be divided by 3, but 69 divided by 3 is just 23 and 3. Those are both prime numbers, so we want to keep it under the root, 69. But we know the square root of 4 is 2, and we just have to apply plus or minus because we essentially took a square root of that fraction. And the last thing we do now is just subtract the 5 over 2 over. So our answer in this case is negative 5 over 2 plus or minus square root of 69 over 2. Or if you want to write a little bit nicer, you can write as negative 5 plus or minus square root of 69 over 2. And that right there is the solution using the completing the square method. As mentioned earlier, when you want to complete the square, the first thing you want to do is get your a term as a 1. So if it's not 1, as the case of this equation here, we wanted to make it a 1. So for the 2x squared plus 4x plus 4 equals 10, first thing we do is we want to make it 1, is we divide everything by 2. Every single term by 2. So when we do that, that'll give us x squared plus 2x plus 2 equals a 5. Now, let's move that plus 2 on the left, move it to the right side by subtracting. So we get x squared plus 2x equals to 5 minus 2 gives us 3. Now our b in this case is 2. So we do 2 divided by 2 squared 2 divided by 2 is 1, squared is still 1. So we now add that 1 to both sides of our equation. So we're going to have x squared plus 2x plus 1 equals to 3 plus 1. So now we do is the left side is now a perfect trinomial, means that the perfect square would just be x plus 1 squared, and the right side is just 4. Now we apply the square root property to get rid of our square on the left. What we do on one side, we do to the other. So left with x plus 1, but then the square root of 4 is 2, but because it's square rooting, it's plus or minus 2. So that means that our equation, we're going to have two separate equations now. X plus 1 equals 2, and x plus 1 equals negative 2. So solve for x, we subtract 1, gives us x equals 1, and x equals to negative 3. And that is our solution to the equation. There are some instances where using the quadratic formula might be the best way to solve your quadratic equation. So when you have the standard form ax squared plus bx plus c equals 0, the quadratic formula states x equals to negative b plus or minus square root of b squared minus 4ac all over 2a. So let's look at the example right here. 7x squared plus 4x minus 3. So identify what your ABC is. 7, b is 4, and c is negative 3. So applying our quadratic formula, we would have negative b, so negative 4, plus or minus b squared, so 4 squared, minus 4 times a, 7, times times c, which is negative 3, all divided by 2 times a, so 2 times 7. So that will give us negative 4 plus or minus. So we're looking here inside the square root. 4 squared is 16. So we have negative 4 times 7 is negative 28 times negative 3, which is 84, positive 84, all divided by 2 times 7 gives us 14. So now if we add up the inside, 16 plus 84 will give us 100 over 14. And we know the square root of 100. That comes out nicely as just 10. So it'd be negative 4 plus or minus 10 over 14. So lastly, we would say x, we can simplify it by dividing each term by 2. X will just be negative 2 plus or minus 5 over 7. That means that we can split this into negative 2 plus 5 over 7 and negative 2 minus 5 over 7. So negative 2 plus 5 is 3 over 7. That's one solution. And the negative 2 minus 5 is negative 7 over 7. Gives us 1. X equals to, and it'll be negative 1. So those are solutions using the quadratic formula. So the quadratic formula can be used in most cases for quadratic equations, but sometimes it might be easier to do a factor, or sometimes it might be easier to use a quadratic formula. It all depends on what your equation is. Let's look at the example that we used earlier for completing the square and apply the quadratic formula to it. So x squared plus 5x minus 11. So you know that our a is 1, b is 5, and c is negative 11. So applying the quadratic formula gives us negative b, negative 5 plus or minus 5 squared minus 4 times 1 times negative 11, all divided by 2 times 1. So that gives us negative 5 plus or minus. So if we square, 5 squared gives us 25. And we have negative 4 times 1 is negative 4 times negative 11 gives us positive 44 all over 2. So if we add up the inside of our root, 25 plus 44 gives us 69 over 2. But if you try to rationalize 69, the only factors of 69 are 3 and 23, which are both prime numbers. So because we can't do anything with that, we keep it in the 69 inside the square root. So that tells us our solution, x is equal to just -5 plus or minus 69 all over 2. Which, if you notice, is the same exact answer we got when we completed the square. On our last example here, we have 3x squared minus x plus 4. So applying the quadratic formula, knowing that a is 3, b is -1, and c is 4, that will give us x equals to -1 plus or minus, so we have -1 squared minus 4 times 3 times 4, and all of that's still under the square root, over 2 times 3. So that will give us +1 plus or minus. So if we square 1, that's 1. -4 times 3 is -12, times 4 is -48 over 6. So if we simplify the inside of our square root, that will give us a negative number. In this case, it would be -47 over 6. So because it's a negative square root, we have to turn it into a complex number, or our imaginary number. That will give us I squared 47 over 6. And then 47 is actually a prime number. Can't do anything with that, so we keep it as under the square root. So that means our answer will just be 1 plus or minus I squared 47 all over 6. So it's okay to have complex numbers as solutions to quadratic equations. In this case, you would do that. You would have to use quadratic formula because you wouldn't be able to factor this quadratic equation nicely